take a look at Chapter 1 and start filling out our study guide in the process. What I'm going to do is I'm going to show you where to go to get the study guide, how to handle what you're going to do with the study guide, and then we're going to go to the study guide and start filling it out. I'm not going to fill out everything, but I'll point you in the right direction of where to go to get the information that you need from the chapter. So we'll start in our Canvas course and let's go to the study guide assignment. So if you click on the study guide assignment and you scroll down, there will be the study guide. So you have a few options at this point. You can print out a copy of the study guide so that you can write directly on it, or you can have it up on your screen somewhere so that you are able to look at what the questions are so that you can write them down on a separate sheet of paper. You don't have to write out full big word problems. Things like the definitions, the vocabulary, you probably want to write the word and then the definition. But for things like problems where there are multiple scenarios and things, you don't have to write it all out. For this one, you could do 3A and write down what your answer is for it. At the end of the day, you are using these study guides for your benefit, not for mine, for your benefit. You're using it to dig into the material to make sure that you are getting everything you need to get out of the stuff that you are reading so that you can be successful in the homework and the exams, and so that you can understand the concepts and use them as we move through the course and beyond, and so that you have a study guide that you can use as part of your notes for your open note exams throughout the semester. So the more you tailor this to something that you can use, the better. If you have a printer, or if it were me and I have a printer, I would print these out, 3-hole punch them, and keep them in a binder. Fill them out, keep them in the binder so that I have them all together. If I were me and I didn't have a printer, I would get a 3-ring binder and loose leaf paper, and I would start keeping these organized in a binder using loose leaf paper. Or I would get a notebook, some sort of a notebook, and keep them in there. Just some way to keep them organized because you will want to go back to them later on. So again, you can download this and print it, or you can just have it somewhere where you can see the questions so that you can follow along. Okay, so once you've got it in a place where you can use it, however you're going to use it, what you'll want to do is start going over what the instructions say to make sure that you understand them. Oh, the other option, what I'm doing right here on the screen over here is I've got my iPad and a stylus. If you have that type of setup, you are more than welcome to do these digitally as long as you are writing by hand. These need to be handwritten and not typed for a few different reasons. If you want details about why that is, you're more than welcome to schedule a little meeting with me. But it is important that these are handwritten notes that you have here. So look at the instructions. The instructions say complete it as you get ready for the homework. You can, exactly what I said, print out a copy to use as a worksheet or write your answers on separate paper. When you're done, you're going to scan all of the pages, save it as a single PDF, and submit it to this week's study guide assignment. So that's the general process. Those instructions are going to be the same for all of the study guides. And then we get into our chapter objectives. So take a peek at these. It might not make sense to you before you actually start reading the chapter, but you'll recognize these things as they get covered in the chapter so that you know you're doing the things that you're supposed to do. So you are going to, by the time we're done with this, be able to recognize and differentiate between key terms. And you'll look through the file there. There's a bunch of different key terms, and some of them are super similar. So recognizing and being able to differentiate, not a small task. Apply various types of sampling methods to data collection. That's a thing that we'll be able to do. And create and interpret frequency tables. So those are the objectives. And we'll come back to those at the end of the chapter to see how we feel about whether or not we can do them. So let's dig right into it. I'm going to keep the study guide open over here, and then I'm going to, and this is probably something you want to do as well, go to our course page, and under this week's module, there is a link to an interactive version of Chapter 1. So click on that, and it's going to take you to Chapter 1 in the textbook. I don't think you want to look at it in a tiny little window. If you click on it, it'll take you and load that up into a whole new tab for you so that you don't have to scroll around quite as much. There is a table of contents that you can click on for the book, and we're looking at Chapter 1. This is the introduction page. It's got those same chapter objectives there, and there's a really, really brief introduction to what the chapter is about. I encourage you to read it. I don't have any questions for you from that or anything to put into the study guide, but it does really set the stage for why you are even taking this class, beyond the fact that your advisor said you needed to for your degree program. So there's some stuff that you are actually going to learn that's going to be beneficial for you. So the chapter 1.1, so this is section 1.1, and you could get to it just by clicking here directly, and you can see 1.1 in our study guide here, and we're going to fill in some things in that. So I see here that the things that are being asked for in the study guide are a couple of definitions, and there's a practice problem, and I believe that, oh, nope, there's a lot of definitions. So we got a lot of definitions to work through. So keep an eye out for these words. It's not going to be hard to find them because they're actually bolded in the text. And when you see them, write down the definition. The definition doesn't have to be the definition from the book. It can be the definition from the book. It needs to be something that helps you remember what the word means. That's the most important thing. So the chapter starts out with this exercise that they talk about that if we were all together in a class, we could do. I could go around the classroom, ask everybody how much sleep they get per night, and we could make this dot graph and look at it. And this is just an example of a dot plot. A dot plot is one way to represent information. So if this is average time in hours spent sleeping per night, one person slept for 5 hours, another person slept for 5.5 hours, 3 people slept for 6 hours, 4 people slept for 6.5 hours on average. And you notice that these dots match up with this data. And for now, that's the important thing. This dot plot tells us, well, it looks like more people sleep for 6.5 hours than anything else. Looks like some people get a lot more sleep, or one person gets a lot more sleep than the one person that gets the least amount of sleep. So we can see a lot of information here. We'll get into more about the specific types of ways to represent data later in the chapter. But for now, this was just an exercise to see what you see in that information. And you're more than welcome to spend a little time answering those questions to yourself. At the end of the day, though, I see the first bold word that we need, descriptive statistics. And I also see the second one that we need, inferential statistics. And so the difference between descriptive and inferential statistics can be a little bit confusing, but the words actually give us the clues that we need to be able to do it. So organizing and summarizing data is called descriptive statistics. I don't like that definition very much because it doesn't get at what we're doing. Descriptive statistics oops, I actually need to have the pen going if I'm going to write on this. Statistics that describe existing data. So if the data exists, descriptive statistics describe. That to me feels like it should be a super, super obvious definition there. And what I mean by that is if you've got a bunch of numbers, you can take the average of those numbers, the mean of those numbers, and that's a way to describe numbers that exist. You could find the lowest number, you could find the highest number, you could find the number in the middle, you can find all of those things, and each one of those is a way to describe the data that exists. And so I would say statistics that describe existing data, and maybe I would say something like the mean, mode, and median of a list of numbers. And if you're not sure what mean, mode, and median are, we'll get to that. We'll get to that too. Don't worry about it. So then what's inferential statistics? If descriptive statistics describe data, inferential statistics let us infer something. It lets us make a prediction about something based on things that exist, but making a prediction about something that we're not sure about. And so it says here, the definition that they're giving us, after you've studied probability, you will use formal methods for drawing conclusions from good data. So if I've got good existing data that has descriptive statistics about it, I can use those descriptive statistics and formulas to be able to do something called inferential statistics. And so inferential statistics is, let's see, how do they say it here? Drawing conclusions from good data. Drawing conclusions from good data. And that would be something like taking the data that we see on the screen there, the data that we've got about the average hours spent sleeping per night. So using data from, oops, I can actually spell, I promise. Using data from the class sleep question to determine a possible sleep average for the whole school. So if I have enough data points, if I've asked enough people in the class and the data is good enough, I could use that and some techniques that we'll learn about to say, well, the class average was about 6.5, so we expect that the average of the entire school would be about that. Now, I don't know from the information that's here, and whether or not that's true. I'm pretty sure we don't have enough information to do that, but I could ask 1,000 people how many hours they sleep per night and make some predictions about the general population based on that. Or I could ask a specific group. I could talk to student athletes and ask student athletes how much they sleep per night versus non-student athletes. And I could say things like, I predict based on the results of my survey of 100 student athletes and 100 non-student athletes that student athletes sleep more than non-student athletes do, or student athletes sleep less than non-student athletes do. I don't know for sure because I haven't asked all of the student athletes in the world and all of the non-student athletes in the world how much they sleep. If I could do that, I could get descriptive statistics that describe what everybody told me. But because I can't ask everybody, I'm going to have to use data to infer something about a group that I can't get descriptive statistics on. So the difference between descriptive and inferential: descriptive describes existing data, inferential uses those good descriptive statistics and statistical methods to make predictions or draw conclusions about bigger groups of people that we can't all talk to, or bigger doses of medication, all sorts of things. But descriptive describes, I don't know why it doesn't say that anywhere in the book, and inferential is making inferences using statistical methods. And so that's those two definitions. And to make sure that we understand that, I'm going to see if I can make this a little bit bigger here. Maybe if I flip this on its side, we might have to do a little bit of flip-flopping between screens here. But we'll, whoops, nope, make this work. So this next set of questions asks you to determine whether they're talking about descriptive statistics or inferential statistics. So based on what we know, is it describing something that we know all of the information about by giving averages or the number of something that we know about, or is it using data to make an inference about something? So for part A, a political analyst is interested in predicting the outcome of an upcoming presidential election based on polling data from 500 registered voters across the country, or 5,000 registered voters from across the country. So predicting something, that's making an inference. He's got data from 5,000 people, and he's going to use that to predict the outcome of something. So that is inferential statistics. We can't ask everybody who's going to vote how they're going to vote, but asking enough people could give us a good idea of what the outcome might be. So for part B here, an esports team manager wants to know the average reaction time of their current players. They measure the reaction time of all 12 team members. So they're getting all of the information that they need. So that is descriptive statistics. They can get the average reaction time because they're going to get the reaction time of everybody on the team and divide it by 12. And that's taking data and describing it. They're describing their esports team using existing data. That is descriptive statistics. If you were doing this on a separate sheet of paper, again, what that would look like, let me make a quick note here so you can see. If I were doing this on a sheet of paper separately, I would, for this question, oh, I just added a page for no good reason. I would, for this question, I would be in 1.1. I would have done descriptive statistics. I promise I normally write nicer than this. So number 1 here, the definition and anything I want to write about it. I would do inferential statistics. And definition, whatever I wanted to write about it. And then for 3, because we've got A, B, C, D, and E, I would do 3A, B, C, D, E. And we said A was inferential and B was descriptive. That's enough for you to know what the answer is. That you can always go back and look at the questions if you need to, but for what you submit for this assignment, if it looks something like this, that's going to be absolutely fine. Okay, so let's go back and we'll do one more of these, but I'll let you do the others on your own. So the National Basketball Association wants to report the total number of three-pointers scored in the entire league during the last season. They have access to all of the statistics. So if you want to describe the number of three-pointers and you know how many points were scored, that's descriptive, right? They're not trying to predict how many three-pointers will be scored next season based on the scores from the past 5 seasons. That would be inferential. They have the data and they're going to assign values based on that data that describe things. And so they've got all of the game statistics. They know exactly what they're talking about. Descriptive describes existing data. And I'll let you take a shot at D and E, but same idea. And hopefully you can figure that out. And there are going to be questions in the homework, the WebAssign homework, that do a very similar thing. And so, yeah. So let me flip this back up on its side again. And we'll go back into the book. So the next thing I'm looking for is the definition of probability. You can just skim and find the definitions. If that's a technique that you want to use, I think it's probably a better idea for you to read the chapter, and when you come across the bold word, see if it's in the list. At the end of the day, I don't know how you study best. You know how you study best. And if you don't know how you study best, set up a meeting with me and I will help you figure that out so that we can be as successful as possible. But use these study guides in ways that make sense for you. So, definition of probability here. There's a whole section on probability. Probability is, well, it says it's a tool used to study mathematical randomness. It's about the chance of an event occurring. So they're saying things like if you toss a coin. If you toss a coin 4 times, we expect when you flip a coin that it's going to be either heads or tails. So there's a 50% probability that each time you flip it, one or the other comes up. That doesn't mean that if you flip a coin 5 times in a row, or, well, let's not use numbers that have decimals right now. If you flip it 4 times, you're not necessarily going to get 2 heads and 2 tails. But if you flip it 1,000,000 times, you don't even have to do it 1,000,000 times. If you flip it, here, what did they say? They did 24,000 times and got 12,012 heads. That's pretty close to 50% or 1/2 or 0.05 or 0.5. The book authors did it 2,000 times and ended up with also something really, really close to 0.5. And so probability, we know what it should be. Probability tells us what should happen if you do something enough times. It will eventually do that kind of thing. And so probability definition in the book here, a mathematical tool, used to study randomness, and it tells us the chances, or the chance of an outcome. Oops. And again, you don't have to do words here. You could do bullet points. You could draw a penny. There's my beautiful copper penny, 1 cent. Flip, and that it lands on heads. You get a 1 out of 2, and that's the same as 0.5. And so this is just reminding me visually that probability is going to be some sort of a number that tells me how likely something is to happen. Probability is going to be, I know this, our book doesn't really say it, and I think it'll say more about it later on, but probability, if something is never going to happen, the probability is 0. Like if I roll a 6-sided dice or a 6-sided die, the probability that I roll a 7 is 0. I can't roll a 7 because the numbers 1 through 6 are there. So I could have the probability that I roll 7, but that's going to be 0 because there's no way to do it. If something is definitely going to happen, then that probability is 1. That 1 is like 100% chance that something's going to happen. If I roll a 6-sided die, I am going to roll a number less than 7. That's guaranteed to happen. And so that's a 1. We'll dig more into details about probability, but for now, that's a good enough definition. And you can also, you could Google coin flip simulators and see how long it takes to get that expected probability. Let me actually do that really quickly. So, coin flip simulator. Like random.org sounds like where I want to be. So I want a, oh boy, I don't know what difference it makes, but let's flip a US penny, and I'm going to flip one of them. And if I flip it, I could keep track of what's happening. I'm getting heads, I'm getting tails. Or I could go back and flip. Nope. Go back and went too far. What if I flipped 200 coins? Then what happens? I could keep track of that. This is going to require you to write down a lot of information. It might be interesting for you to do that, but there are coin flip simulators that will tell you exactly how frequently it's heads or tails. I also kind of want to look at all of the cool coins, but not now. We got to get back to this. So you could look at different types of probability simulators to see how that works. So we've got some more terms here. Data. And for some reason, I did not include the word population in this list. So bad on me. We do need to pop that in here. So I'm going to also add the word population up here. Define population. And population is the group or collection of things that we want to know something about. So if I am looking at coin flips, I want to know about the population of coin flips. If I want to know about who's going to vote for whom in an election, I want to know about the population of the United States. Or maybe I just want to look at the population of a single state. Or maybe I want to look at all of the people under a certain age in the US. That becomes a population. Whatever I'm studying, that's the population. So the group or collection we want to study. And then sample is some part of the bigger group. So if I want to know something about all of the students at Vermont State University, I can't necessarily get in touch with all of the students at Vermont State University, but I could ask all of the students in my classes a question and use that to try and make some sense about the bigger group of students at Vermont State University. It's probably not the best way to pick a sample, but that's one way that you could do it. So sample is a, how do they say it in a portion of the population that we can use to get information about the whole population. The word population here is a little bit tricky because when we see that word, we're so used to using it to talk about people. So we talk about the population of a country or the population of a city, but we don't necessarily. Population could be, I've got a ball pit full of different colored balls, and the population is the balls in the ball pit, and I'm going to take a sample of those. So I'm going to take 50 balls out of this giant ball pit as a sample to help me predict the makeup of the colors of balls in the entire population of balls. So you don't have to have people to have a population. Population can be any group or collection of things. And then data. Where is the word data? Data are the results of sampling from a population. So data, the result of sampling from a population. So if my, let's say it's the ball pit example here. So example, population is all of the balls in a ball pit. The sample is 50 balls from ball pit, and the data then would be 50 of R, R, G, B, Y, R, B, Y, Y. And those are all of the colors of the 50 balls that I pulled out of the ball pit. And that data is just the information that I collected from my sample of the population. Population, all of the balls in the ball pit. Sample, the 50 that I pulled out. Data, the colors of the 50 balls that I picked out of the ball pit. Those are those things. Let's see. And then what else do we have here? Sampling. Where's the word sampling? Sampling, a very practical technique. So the idea of sampling is to select a portion of the population and study that portion to gain information about the population. So sampling is getting info from a sample, a subset of the population to learn more about the population. So that's a step in inferential statistics. It's taking descriptive statistics from a sample and using them to predict things about a population. Statistic. I see that as another word here. A statistic is a number that represents a property of the sample. Okay, well, that's not a very helpful thing. Let's see their description here. For example, if we consider one math class to be a sample of the population of all math classes, then the average number of points earned by students in that one math class at the end of the term is an example of a statistic. And so statistic, that is a number that represents a property of a sample. So in this case, it could be average GPA of who would I be interested in average GPAs? Average GPA of statistics students in my class. And I could use that maybe then to say something about the average GPA of statistics students in all of the different sections of statistics. Or I could use it to say something about the population of all students at VTSU. It's, but yeah, it's a number. So it could be an average. It could be a median. It could be a mean. It could be anything that we could use to describe that sample. That's a statistic. And then we have parameters. A parameter is a numerical characteristic of the whole population that can be estimated by a statistic. That has me flipping in circles a little bit, that definition, because it feels like it's trying to define itself. So it says a numerical characteristic of, what is it? Numerical characteristic of the whole population. Numerical characteristic of the whole population that can be estimated by a statistic. That can be estimated by a statistic. So I feel like I absolutely need to start using these words in a way that is going to help me differentiate between them, because the way it's described in the book right now, statistic and parameter feel really similar, but a statistic, let me see if I can do a diagram. And again, however you do this to make it make sense to you is absolutely okay. So I'm going to say that I'm going to write statistic, sample tells us predict a parameter of the population. And that actually gives us kind of a little memory trick there then. So statistics are talking about samples. You can have the average or mean of a sample and use that to predict the mean of the population. And that's statistics are talking about samples, parameters are talking about populations. And so example using class average to predict school-wide average. And I might even, in this case, sample statistic, class average, population parameter, school-wide average, so that I can see there that that's what those things are. So statistics refer to some property of a sample, parameters refer to the property of the population that could be predicted from that property of the sample. Okay, representative sample. If I want to know the average amount of sleep that student athletes get every night, I want to make sure that I am asking a wide range of student athletes, that I'm not just going to basketball practice and asking basketball players how much they sleep, that I also want to make sure that I go to the tennis practices and the softball practices. And if I'm genuinely interested in all student athletes, I want to make sure that the sample I pick represents all student athletes. So representative samples, we want to, it's a sample that has the characteristic we are interested in knowing more about in the population. So for it to be representative, I want to get all of the student athletes. I also don't need to waste my time asking non-student athletes how much they sleep if all I'm interested in is student athletes. So if my sample just includes everybody in the dining hall one day, I walk in and ask them how much they slept, that sample isn't going to tell me something specific about student athletes because it's not representative of the population that I'm interested in. So that's what a representative sample is. Then we've got variables. I'll let you write down what a variable is. I think you probably can come up with that. And they're saying that there are two different types of variables, two broad categories of variables that we can use. We can use numerical variables. Numerical variables, they have numbers. That's a pretty good sign. And so how do they define it here? Numerical variables take on values with equal units, such as weight in pounds and time in hours. So numerical values, I think for my purposes, I would say that they what does it say? They, how do I want to say it? Variables that, can be measured in, what did it say? In equal increments. And so that's example, pounds, oops, not pounds. The variable here and the increment here. Variable is weight. Increment could be pounds. It could be other things. For now, we'll say pounds. Variable could be height. That would be, let's do centimeters. Centimeters. Variable could be speed, and that could be miles per hour is the increment. Temperature, degrees Fahrenheit. Those are numerical variables. Those are how those can be measured. And then we have categorical variables. And so categorical variables put things into categories. Numerical variables assign numbers to things. Categorical variables put them in categories. Variables that put things in categories. And so, example, we'll do the variable and the categories. The variable is color, and the categories red, blue, yellow, green, or however many categories you happen to be interested in. We can categorize it that way. Variable is the coin flip result, and the categories are heads or tails. The variable could be year in college, and the categories are freshman, sophomore, junior, senior, super senior. Those are categories. So if the data you're collecting is putting things into categories, it's categorical. If the data you're collecting has numbers that describe equal increments of something, then it's numerical. So one tricky bit here, so here's this interesting thing to note and not get caught up in. Place in competition. So let's say we've got some sort of race, and someone comes in first, someone comes in second, and someone comes in third. Those are numbers, but those numbers are not equal increments of anything. They're just numbers that categorize. How many times did somebody come in first? How many times did someone come in second? How many times did someone come in third? They're numbers, but they're numbers that are categories. They're not numbers that are measurements of something. And so that's kind of a difference. And so you might even want to go back to your numerical values and really think about this word, that measured, because we measure things in those even increments, and we can use numbers in ways that don't involve measuring. So just a thing to think about. All right, data. I feel like we have defined this word before. We have defined this word before, but let's see what it says here. Data is the value of a variable. So that's another way to describe this. So the value of a, the values of, gotta be careful. The values of a variable, or the variable that we're looking at. Oops. The variable. And make a note too, they say here in the textbook, datum is a single value. So data is red, green, blue, yellow, purple, all of the things that I got when I pulled balls out of the ball pit, all of those together are the values of the variable. Datum was one red ball. It's one example of the values that you're collecting there. Data could be heads, tails, heads, 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 heads. Datum, one flip was tails. So datum is just the singular version of data. Mean and proportion, those are things that we probably remember from previous classes. Mean is average, and that is add up all the numbers and divide by the number of numbers. Number of numbers. But I think you know how to take an average. So if I add 3 numbers together, I divide by 3, that gives me the average. If I add 10 numbers together, I divide by 10, that gives me the average. And then proportion is the relationship between two different numbers. And so it's just comparing two different values. And so proportion is a comparison of two values. And so the proportion of, the proportion of strawberry starburst in a pack might be 4 out of the 10 pieces in a pack. So 4 strawberry, 10 total. That's a proportion. And we'll talk more about those as the semester progresses. So mean and average, technically not the same thing, but it's okay to use those interchangeably in this class. not a problem at all. There are some example problems here that look very much like the example problem that I've got in the practice guide. So you can practice with the example problems in the book. Here we've got one where they give you the question and then you can look for the solution and then try it out on your own in the study guide. So I'm going to look at the study guide here really quick. Let's do a couple of these. We don't have to do all of them. Oops, I turned it sideways. That's what made it get bigger. There we go. So, a researcher is investigating the average daily screen time of teenagers in a small town, and we need to figure out which of these things describes which of these terms describes the different things. So the researcher is looking at average daily screen time of teenagers in a small town. So the population is all of the teenagers that live in the town. Remember, that's the group that we want to know about, the population. It's not all of the people in the town because we're not interested in all of the people in the town. We're interested in all of the teenagers in the town. Statistic. Well, what was a statistic? Let's go back and look at what a statistic was. A statistic was a number that represents a property of a sample. And so statistics go with samples. So when I look at this list of things, the average daily screen time of teenagers in the study, that's actually what I want. I want the average of the sample, the teenagers that are being studied, not the average of all of the teenagers. That's the parameter that I'm interested in. The statistic is the teenagers in the study. And so I just gave that away. The parameters is the the average daily screen time of all teenagers in the town. And so that gives me that. So parameter goes with population, statistic goes with the sample. So what's the sample? From that list of things, it would be the group of randomly selected students, right? That's the subset of the population. It's a smaller group that is representative of the population, or hopefully representative of the population. Variable. Variables, what was our official definition of a variable? We didn't even write it down because we said it was too obvious, so let's see if it's obvious. Variable is the daily screen time. That's what we're interested in knowing, right? And that changes from person to person. That is B. And data then would be something that looks like the information collected. And so that would be F. And it turns out that we used A, we used B, we used C, we used E, we used F, and we used G, but we didn't use D. And this reflection question asks us, what is the term for the option we didn't choose? So what is the term for the daily screen time of one teenager in town? And I'll give you a hint. If you look back up here, we had the difference between data and datum. I think that'll give you that answer there. So, if you are working on these study guides and you can't figure out the answer to one of the questions, you will still get credit even if you write, I'm not sure. If you do write, I'm not sure, or I don't have a clue, or I can't figure this one out, or I'm too tired to think about it, write something there so that it is complete, because I'm grading you on completion on these. And then reach out, book a quick 15-minute appointment with me, or come to one of the student hours on Tuesdays so that we can go through it and make sure that you know how to answer that question. But for the purposes of submitting the assignment, it's okay to not know. It's okay to not know. All right, so that is everything from section 1.1. And your sheet does not have to look like my sheet does. Your sheet needs to look like something you can use to go back and make sure that you understand what's going on. I would strongly, strongly encourage you to go and try out these questions in the chapter to see if you understand what's happening here. So they've got, let's see, a study about the safety of electric automobiles. They were looking at the effects on crash test dummies. They looked at the speed that the cars crashed at and the location of the drivers. And it's going to ask you to figure out, well, what is the population? What is the sample? What is the parameter? What are those things? See if you can look at that question and identify the words that we've defined, because a big chunk of the homework that's due on Sunday is going to be applying those terms to different parts of a statistical inference scenario that they have going there. So, those are the things that we need to look at for section 1.1. I'll make a separate video for 1.2, 1.3, 1.4, and I won't spend quite as much time talking about formatting things in those because we've already talked about that here. So those will go a little bit quicker. I won't give all of the definitions this time because now you know how to find those as you're going through the chapter in the textbook. If there's something like I noticed that I had forgotten to include the word population in the vocabulary list. And if you see something that looks like it might be important or something you want to write down, you can put more on here if you want. There's no restriction to what you can include if it's going to help you to understand the chapter. The things that I included are sort of the minimum that you need to understand to be able to do well on the exams and to really get the most out of the later chapters that we'll be covering. So that is 1.1, and I will see you in the video for 1.2.